Okay, now we can start. Let's go. First, we will start with term of polymers. Polymers are macromolecules that consist of many constituent units. Constituent units are the smallest repeating structural units. The smallest repeating unit is called a mer. The term polymer is derived from the Greek words poly and mers, meaning many parts. We can see the figure which shows the structure of polypropylene, on which we can see the smallest part, mer. We can see mer. It's over here. We can see that consists of two carbons in main chain and one methyl group. So that's mer for polypropylene. Now we will talk about some properties of polymers. They have big molar mass and they are formed by the chemical bonding of small molecules called monomers. The reaction is called polymerization. In the polymerization reaction, the monomers are covalently bonded. And we have one important term, and it is degree of polymerization. Degree of polymerization is total number of basic structural units, including the end group. At the beginning of development of macromolecule chemistry, newly discovered polymers were called by trivial names, some of which are still used today. For example, cellulose, starch, nucleic acids, nylons, etc. And also we have the UPAC nomenclature of polymers. Now there are several classifications of polymers. On one, which is that polymers can be classified by origin, structure, molecular forces, and mode of polymerization. So we will start with polymers based on source. Yes? Is everything okay? Okay, I will take that as yes. Like I said, we will start with polymers based on origin of source. First of all, we have natural polymers, for example, cellulose, starch, wool, proteins, carbohydrates, and nucleic acids. Next, we have synthetic polymers. Synthetic polymers are polyethylene, polypropylene, polystyrene, polyvinyl chloride, polyphosphates, polysilanes. Next, based on structure, polymers can be divided into linear polymers, branched polymers, cross-linking polymers, and networked polymers. Then we have polymers based on molecular forces. We have elastomers. The polymer chains are held together by weak van der Waals forces. They can be stretched like elastics, and also we'll come back to their original shape on releasing the force. For example, rubber. Rubber is typical elastomer. Then we have thermoplastics. Thermoplastics are those polymers which contain intermolecular forces. What? Okay. Thermoplastics are those polymers which contain intermolecular forces higher than elastomers, but less than fibers. Then we have thermosetting polymers, and they are having highly branched chain molecules with extensive cross-linking, and if heated becomes infusible and can be reused. For example, melamine, bakelite, etc. And finally, we have fibers. Fibers are solids that have thread-like structure possessing strong intermolecular force. Due to this strong force of attraction, they have high tensile strength. For example, we have nylon 66, Dacron, etc. This figure shows thermoplastics and thermosets. We said that thermoplastics can be melted repeatedly, but thermosets cannot be melted. Once they shape, they stay shaped. So that's basically the difference. Next classification is classification based on polymerization. Based on type of polymerization, polymers can be classified as addition polymers and condensation polymers. Addition polymers, these type of polymers are formed by the repeated addition of monomer molecules. And condensation polymers, these polymers are formed by the combination of monomers with the elimination of small molecules like water, alcohol, or something else. Now, I have a question for you. Can you tell me where do we see polymers in everyday life?
Well, in the clothes, since it's cotton.
Okay, good. Next, what else?
Rubber.
Yes, great. Rubber is typical elastomer, like we said earlier. Next. Now we will see where we can see polymers in everyday life. Basically, we can see them everywhere around us. We will start with cosmetics. We have polymers in cosmetics, shampoo and conditioner packaging, bottles. Then we have garden furniture, plastics, of course, rubber, like you said, plastic bags for garbage. We have bottles here, frames, clothing, like you said. What is this? Plastic cups, cans, pens, CDs. Now I can't see what is this picture, just a second. Socks, nylon socks, toothbrushes, cars, carpets, and greenhouses. Did you know that these materials are polymers?
No.
No, okay. Have you ever seen these signs on polymer packagings? Have you ever noticed these signs with numbers? We have 1, 2, 3, 4, 5, 6, 7.
Yes.
Yes, I think so.
Okay, but you didn't know what are they meaning. Okay. Here we have a sign with number 1, it's polyethylene. Then sign 2, it's high density polyethylene. 3, polyvinyl chloride. 4, low density polyethylene. 5, polypropylene. 6, polystyrene. And 7 is other. So we have so much polymers, and only these polymers are named by the number, and in number 7 are many more polymers which are not included here in this picture. Okay, so we'll start with polyethylene terephthalate. Polyethylene terephthalate is general plastic thermoplastic polymer which belongs to the polyester family of polymers. Polyester resins are known for their excellent combination of properties such as mechanical, thermal, chemical resistance, as well as dimensional stability. Now we have some products made from PET or PIT. The most common are PET bottles and jars, carpets, clothing, industrial strapping, rope, automotive parts, fiber fill for winter jackets and sleeping bags, construction materials, protective packaging, etc. Okay, next we have high density polyethylene. The sign is here, number 2, and high density polyethylene is a thermoplastic polymer also. It is produced by the monomer ethylene. HDPE is plastic commonly used in making containers for milk, motor oil, shampoo bottles, toys, chemical containers, pipe systems, recycling bags, grocery bags, etc. I will ask you a favor to turn on your camera so I can take one screenshot. Can you do this for me? Just a second. Okay, let's do this. Okay, thank you. Thank you. Next, we have polyvinyl chloride or PVC. The sign is PVC with number 3. Polyvinyl chloride is one of the most widely used polymers in the world due to its versatile nature. PVC is used extensively across a broad range of industrial, technical, and everyday applications, including window and door profiles, pipes and fittings, power, data and telecoms wiring and cables, cable and services ducting, internal and external cladding, roofing and ceiling systems, and membranes. Next, we have low-density polyethylene. LDPE has a number 4. It is a soft, flexible, white-laid plastic material. LDPE is noted for its lower temperature flexibility, toughness, and corrosion resistance, and it has good chemical and impact resistance, and it's easy to fabricate and form. Some products from LDPE are plastic bags for dry cleaning, newspapers, bread, frozen foods, fresh produce and garbage, shrink wraps and stretch films, coatings for paper milk cartons, disposable beverage cups. Now tell me, do you use these bags for grocery shopping or something else?
Yeah, more or less. Usually we are currently we are like adopting to the shoppers, but yeah, we do use them in everyday life.
Unfortunately, we use them so often, but all of us should replace these plastic bags with shoppers from cotton or some other material. So it's bad for our environment to use those plastic bags. Do you agree with me?
Of course.
Okay. Next, we have polypropylene. Polypropylene is also thermoplastic polymer, and it is made from the combination of propylene monomers. We saw it on the second slide, propylene and its mer. It is used in a variety of applications, including packaging for consumer products, plastic parts of various industries, including the automotive industry, special devices. Also, it is used for ropes, twine tape, carpets, upholstery, clothing, camping equipment. Now we have polystyrene. Polystyrene Plastic is naturally transparent thermoplastic that is available as both as a typical solid plastic as well as in the form of a rigid foam material. Polystyrene plastic is commonly used for disposable eating utensils, foamed cups, plates, bowls, rigid trays, and containers. Also, we use this much as well as the plastic bags, and it's bad for our environment. Okay. Now we have one polymer that is in the group other. Polycarbonate is also thermoplastic polymers containing carbonate groups in their chemical structures. Polymers like polycarbonates are easily worked, molded, and thermoformed. Some products from polycarbonates are molds for urethane and silicone casting, 3D printed models for high heat applications, machinery guards, LED lights, pipes and diffusers, vehicle headlights, small vehicle windshields, bullet-resistant glass syringes. Just a second, we have something in chat. Plastic. Someone wrote plastic. Okay, good. I didn't see it earlier. And Francesco said that he has arrived 50 minutes late. It's okay. It's important that you are now here. Okay. Let's see what is the next slide. And now the probably most famous are polyamides. Polyamides are among the most important and useful technical thermoplastics due to their outstanding wear resistance, good coefficient of friction, and very good temperature and impact properties. Polyamide products are textile fibers, carpets, automotive core ties, ropes, bearings for machine parts, also toothbrushes. Those fibers and toothbrushes are from polyamide, as well as socks and other materials, clothing. We can see it on. Sorry, but I can. Okay, Virginia, it's okay. Let's see what's next. We have 15 more minutes. Now we will talk about polymer recycling. Can someone tell me what is recycling? What is meant by the term recycling?
Maybe trying to reuse things that you already had and you thought about throwing it.
Okay, great. Here it says that recycling is the action or process of converting waste materials into reusable material. We have recycling and we have polymer recycling. The most common term is plastic recycling. Okay, polymer recycling is a way to reduce environmental problems. We talked earlier about plastic bags, plastic cups, plastic and other plastic materials. And it's good because it can recover polymers in the form of materials and or obtain new monomers, intermediates, or fuel from the starting material. Okay, sorry. I will have to save this screenshot because I have to do another one or two maybe. Okay. I have to do one with number of participants. Just a second. Okay. Okay, we can continue now. You probably know that plastic can take hundreds of years to biodegrade. For some plastic, it's about 1,000 years for some types. Recycled plastic can conserve limited natural resources and energy. Before being recycled, plastics are sorted according to their design type, manually or using mechanized automated processes. And there are two main ways to recycle plastic. We have mechanical recycling. In mechanical recycling, plastic waste is first sorted by material type, and then is milled and washed, passes a flotation separation, and it's finally dry. And we have chemical recycling. Chemical recycling is any process by which a polymer is chemically reduced to its original monomer form so that it can eventually be processed and remade into new plastic materials that go on to be new plastic products. Have you ever seen in your shampoo bottles that it says that is made from recycled plastics?
Yes.
Yeah, okay, that's good. And Zara and H&M, they are promoting recycled clothes. Have you seen that?
Yeah,
It's
there
really
were
popular
lots
right
of
now. What?
yeah, there were lots of advertisements on TV about it.
Yeah. Okay. We have another recycling classifications. It's primary, secondary, tertiary, and quaternary. And in this table, we can see what is meant by primary, secondary, tertiary, and quaternary type of recycling. With primarily and secondary type of recycling, that recycled material we use as material. If we have tertiary type of recycling, we use that product as a raw material for the production of chemicals. And if we have quaternary type of recycling, we use that product as fuel. Now we have a question how to recycle polymers more effectively. For example, we'll start with paper. What can we do with used paper? First of all, you can reuse printed paper. You just need to flip it over to print it on the unused side. Then you can do some origami. You have plenty of possibilities. For example, paper CD wallet, paper basket, decorations, gift boxes. Then we have wall art, gift wrapping paper. We also have paper mache, or I don't know what is pronounced, piñata, and it is very popular right now for birthdays, parties, and parties. Then we can use paper for window cleaning. I tried, it's really good. Then we have season pots and we have compost. Which plastic can be recycled? Basically, all of these that we mentioned can be recycled, but the most widely recycled plastic in the world is PET. Do you know what we can make from PET? We can make sweaters or carpets, or I don't know, something like this. So it's pretty interesting that we can make it from PET bottles that we use every day for water and juices and other. And also PET bottles can be recycled into PET bottles. They are made of one of the few polymers that can be recycled into the same form. We mentioned clothing, carpets, and we can also turn PET bottles into pillows. Okay, let's see what else we can recycle. We can recycle plastic bottles, juice and milk cartons, plastic jars, salad dressing and cooking oil containers. We can also recycle most cleaning product containers, bleach and laundry detergent containers, shampoo and conditioner bottles, yogurt and butter tabs, shredded paper. Or you can reuse those plastic items instead of using them. You just need to be creative. Now we have some examples how we can reuse plastic. It's all about creativity. We can create supply cups, upcycle laundry detergent bottles into a watering can. We can see that here, herb garden with empty bottles. It's here. Reuse plastic bottles to make a deep Y sprinkler. Where is it? It's here. Decorations. Soon it's Christmas time, so you can make Christmas decorations or make a bird feeder, like this one on the picture. Okay, and that would be it from me. Thank you for your attention.